Hello Calc class, this is the third video for section 4.3 talking about chain rule, finding the derivative of a composite function. The basic ones, they're pretty basic, not much to them, but it does get a little bit more complicated. So I wanted to show you an example of that kind of thing. So what's becoming more and more important as we move on in chapter 4 and seeing different types of functions is identifying what function you're looking at so you know how to take the derivative of this. So looking at this example here, yes, we do have the chain rule. We have a function, this 3x plus 5, that's being raised to the 5th power. But we've also got another factor here. So what we're really looking at is a product rule. Okay, we have a times b. So if our function is a times b, the product rule says the derivative of this is a prime times b plus a times b prime. And so that's really what we need to be doing. But now, if this is our function b, in order to find the derivative of b, because it's a composite function, we need to be doing a chain rule. So the key thing here is this. It's a product rule. We have a function times another function. But inside of that product rule, we're going to have to do the chain rule. So it gets a little bit more complicated. So let's go through this. All right, the derivative of our function y, so dy over dx. We take a prime. So if this 4x is a, our function a, the derivative of that is 4 times function b, 3x plus 5 to the 5th, plus our function a, which is 4x, multiplied by the derivative of function b. So now, take the derivative of function b, we need to be doing the chain rule. So exponent of 5 out in front, multiplied by the 3x plus 5, that gets to the 4th power, multiplied by the derivative of the inside function. So the derivative of 3x plus 5 is 3. Okay, this is the product rule with a chain rule thrown in. Now, just like all the other things, what's next is some simplifying. So really, what we have here is two terms. This is one term, plus this is a second term. The simplifying is going to be doing some factoring. All right, so in these two terms, we have some common factors. The factors of the first term is 4 and this 3x plus 5. We have 5 of those factors because of that exponent. And we got a ton of factors here. We got a factor of 4, we got a factor of x, we got a factor of 5. We have 4 of these 3x plus 5 factors. We have a factor of 3. So what we're looking at is common factors in the two terms. All right, 4 is a common factor. This 3x plus 5 is a common factor. The most we can take out of both terms is 4 of them. Okay, that's all the common factors that we have in those two terms. So we're going to take those out. Now we've got to look at what's left over. So from this first term, we factored out this 4. We factored out 4 of the 5 factors of 3x plus 5. That means there's 1 left over. So that's the only thing left over from the first term after factoring out what we did. Then we got plus. In this second term, we factored out the 4. We factored out these, all of them, all 4 of those 3x plus 5. So what's left over? We got this x times 5 times 3. So that is 15x. Okay. From here, we got 4, 3x plus 5 to the 4th. Inside of this bracket of the things that were left over after factoring, we got some like terms. 3x plus 15x is an 18x plus 5. Okay, and we can go one step further by distributing this 4 into that bracket. So let me raise the page up a little bit. So what we have is 3x plus 5 to the 4th power. That is multiplied by the quantity of 4 times 18, 72x plus 20. And now we are done. This is our derivative, dy over dx. So when we start changing up our function, again, the key thing is identifying what type of function we're dealing with. We really had a product here, so we had to do the product rule. Inside that product rule was some chain rule to find the derivative of function b. And then once you apply that product rule with the chain rule in it, that was this first step up here, it becomes factoring and simplifying what's left over. Okay, that's a little bit more complicated. I'll do one more video here where you got to do a quotient rule with chain rule thrown in there. I look forward to it. I hope you do too.